In this slide deck, we use two videos to introduce the Bernoulli trial and the binomial distribution. In this first video, we will present the Bernoulli trial, which is a single coin toss. The Bernoulli trial is the workhorse of introductory courses in undergraduate probability. In the second video, we will describe the binomial distribution. When looking at the binomial distribution, the experiment of interest is not a single coin toss, but instead a series of coin tosses. In both videos, we will describe the physical system being modeled and discuss the corresponding probability distribution, average, and variance. We begin by describing the Bernoulli trial, which we manifest by tossing a penny once. We represent the possible outcomes using the single variable x. If we obtain no heads, meaning tails, we say that x equals 0. And if we obtain heads instead of tails, we say that x equals 1. X is the number of heads we obtain from an individual toss. Depending on the fairness of the coin, the outcome of tossing a coin 100 times might be, for example, 60 heads and 40 tails. We can express this probability distribution in terms of numerical frequencies. By convention, p represents the fraction of tosses that land with heads facing up, meaning the fraction that produces so-called success. And 1 minus p represents the fraction of tosses that produces tails, also called failure. The two frequencies 1 minus p and p must add up to 1. For the purposes of this slide deck, we will regard this bar chart, which is obtained by performing the Bernoulli trial 100 times, as though it represented the bar chart that would be conceptually obtained by imagining a process of performing the Bernoulli trial without end. What is the average number of heads? Using the definition we learned in the previous slide deck, we take a sum over values of x, using the probability distribution p of x as a weighting factor. For a large number of trials, we get the result 0 heads, 1 minus p of the time, and we get the alternative result 1 heads, p of the time. Because there is a 0 in the first product, only the second product, namely 1 times p, survives, and so the average of x equals p. What is the variance of the number of heads for individual tosses? Using the definition from the previous slide deck, we take a weighted sum of the square of the deviation of x from its average value. When the outcome is x equals 0 heads, the squared deviation is the square of 0 minus p. This occurs 1 minus p of the time. When the outcome is x equals 1 heads, the squared deviation is the square of 1 minus p, and this outcome occurs p of the time. The square of 0 minus p is simply p squared. Both terms contain at least one factor of p and at least one factor of 1 minus p, which can be factored out front, leaving behind in the square brackets p plus 1 minus p. But this is equal to unity, so the variance in the number of heads x is simply p times 1 minus p. We have just studied the probability distribution and statistics for a single coin toss as summarized to the left. In the next video, we will investigate the probability distribution and statistics describing the outcomes of a series of tosses as summarized to the right.